Okay, in this video, I'm going to give you a little intro on Lewis diagrams, and I'm going to show you Lewis dot diagrams. And in the next video, I'll go over more on how to draw a little bit more complex diagrams. All right, so here is one Lewis structure right here. And basically, a Lewis structure is just showing you how the electrons are arranged in a molecule. So right here, the hydrogen is sharing 2 electrons with the oxygen, and same thing for this hydrogen, it's sharing 2 electrons. And then oxygen also has 2 more pairs of electrons right here, because it just shows you where the electrons are, and that's going to be very important for determining properties and things of that nature. And so again, this is another Lewis structure, and it shows that it's sharing 2 electrons here. So every dot is an electron here. All right, so now some of the more simple diagrams just have 1 atom, and we're just going to show the valence electrons. So the valence electrons are the electrons involved in bonding. So that's all we're concerned with. So silicon. Let's go ahead and look up silicon on the periodic table. If you look it up, the element symbol is Si. So in order to draw just a Lewis dot diagram of an element, you're going to put the element symbol, and basically you're going to act like there's a little box around it, and then you're going to show the valence electrons in this atom. And you're just going to place dots around it to show those valence electrons. So silicon has 4 valence electrons. It's in group 4A. All right, so I'm going to place 4 dots around the silicon. So I'm going to place one here, one here, one here, and one here. So this is a Lewis dot diagram of a sulfur atom. It shows the 4 valence electrons around it. And typically, you're just going to put 1 electron at a time, or 1 dot at a time. All right, let's look at sulfur. Sulfur is in group 6A, so it has 6 valence electrons. So we're going to have 6 dots on this one. So sulfur is just S. Act like there's a little box here. So put 1 electron here, 2, 3, 4. We've got 2 more, so 1 more. So now I've got 2, 4, 5, 6. 6 valence electrons around each sulfur. Now let's do magnesium. Magnesium's in group 2, so it has 2 valence electrons. All right, so magnesium is Mg. So I'm just going to place the electrons around it. So 1, 2. So the dots will show you how many valence electrons you have. And these are just simple atoms. All right, so let's look at what happens when you bond. All right, so let's look at magnesium chloride. All right, so the formula for magnesium chloride, well, we have a metal, so this is an ionic compound. So we're going to look at the charges. Magnesium's in group 2A, so it has a +2 charge when it becomes an ion. Chlorine is in group 7A, so it has a -1 charge when it becomes an ion. So the formula should be MgCl2. I'm going to have 2 chlorines for every 1 magnesium. All right, so let's just look at the electron dot structure for just magnesium. Okay, magnesium is Mg. It has 2 valence electrons, so 1, 2. Now let's look at chlorine. All right, so chlorine is in group 7A. It has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. All right, let's look at this right here. We have 7 valence electrons. In order for it to be satisfied, it would need 8, because 8 is going to pull it to a stable energy state. So what ends up happening is that this magnesium wants to get rid of 2 to become like a noble gas. So one of these electrons gets transferred right here. Well, then you have chlorine, and it has 8 electrons now. So this is after it becomes an ion. Okay, and I'm going to put -1 charge right by it. Now this one's good, but now magnesium has 1 and it still wants to get rid of one of the electrons. So we have another chlorine. And chlorine should have 7 valence electrons, like this one right here. And this electron can get transferred here. So then what I have is another chlorine ion. And now it has 8 electrons. And it has a -1 charge because it has an additional electron. Well, magnesium, at this point, it's lost both of its valence electrons. So now, at this point, this is what it looks like. Mg, no electrons. And now it has a charge of +2. So when you have an ionic compound, these electrons get transferred over, and then something loses electrons, and something gains it. And then they would stick together as an ionic compound at this point. All right, so let's look at something covalently bonded. Okay, carbon tetrahydride. All right, so carbon tetra, if I see the prefix, I just go with the prefix. So carbon would have 1 atom, tetra would be 4. All right, so now I'm going to look at each individual atom. Carbon is in group 4A, so it has 4 valence electrons. 1, 2, 3, 4. Hydrogen has 1 valence electron because it is in group 1A. All right, so now if I had 4 of these, like this, each hydrogen actually wants to gain an electron because hydrogen's configuration is 1s1. If you had 1 more electron, you'd actually have a full energy level. It doesn't want 8. Most do want 8, but not hydrogen. Hydrogen only wants 2. So right here, carbon wants to be satisfied. It wants to gain more electrons too. So what ends up happening is these 2 atoms will share the electrons. These atoms will share. So in the end, you have all hydrogens sharing electrons with carbon. So instead of the transfer, which you'll have is something like this. So the bond, instead of transferring the electrons are being shared between the atoms. And then this would be a Lewis dot structure for this compound right here. In the next video, we're going to go over a lot more details on how you actually come up with a structure.